All right, part three of chemistry, week five. Left off talking about these examples as we go through them, whether you multiply or divide. It's all starting with what you're given. Now, here's where we left off with lithium, 1 gram. So we're going to start with 1 gram, and then in our parentheses, grams is going to go on the bottom, so I can cancel. Well, anything to do with mass, I have to use the periodic table. So use the mass off the periodic table for grams is always going to be equal to 1 mole on top. So I'm going to divide those two, but then that's going to tell me how many moles. Does that answer the question if it says how many atoms? No, I'm going to have to do one more step, and then I'm going to take that, how many moles that I just found, and I'm going to put 1 mole on the bottom. And since now I'm going to atoms, molecules, or formula units, I'm going to use the 6.02 times 10 to the 23rd, and then that's going to go on top. So I'm going to go, first of all, start with 1 divided by the molar mass of lithium and then multiplied by 6.02 times 10 to the 23rd. And we would get 8.67. So how much would atoms? You'd do the same thing. Start with atoms here. But if I want to go atoms to mass, there's no mole in there. So I have to a two-step problem. Atoms, start with atoms. Divide it by 6.02 times 10 to the 23rd atoms in every 1 mole. And then you're going to multiply it by 235. I think that's what uranium, 238, if you look on the periodic table. So it's going to be a divide, then multiply, and you get 13.6 grams. Okay, you got the answers there. You'll be able to check. What I want you to notice, though, those weights in those masses that we got, the molar masses, are all for single elements: carbon, magnesium, lithium, uranium. It's not for molecules. So what if we have molecules? So if we want to calculate the formula mass, or what's going to go in our parentheses of something that is a compound, whether it's molecular or ionic, you have to add up all the individuals. Magnesium carbonate that we learned last chapter, the name, you have to add up all the individuals. Well, how many magnesiums are there? Well, there's 1. That's 24.3 grams per mole. Carbon is 1, so it's 12.01 grams per mole. And then there's 3 oxygens, so I'm going to take the 15.99, or just 16, you can round it. 16, I'm going to multiply it by 3. Add all the total up, and then you get the formula mass. That's now what will go in, changing from moles to mass and so on. I'll give you an example here when we get a chance. Now, they do use different names. So if you have questions out of the book, they say gram molecular mass. That's the same thing. That's for molecules. Gram formula mass, that's if it's an ionic compound. And then the one that we talked about earlier, gram atomic mass, is when it's only an element. Again, you have those 3 things that we used for representative particles. So if we had sodium sulfide, when you look at that, if we want to know what type it is, first of all, that's ionic, right? Metal, non-metal. So we would use, instead of formula unit, it's called a gram formula mass. Add up 2 sodiums, 1 sulfur. 2 nitrogens, 4 oxygens. Add them all up to find the whole thing. And this is a molecular mass. Why? Because that's a molecular compound, non-metal, non-metal. Dinitrogen tetraoxide. Now, this one would be a gram atomic mass because carbon is just 12.01. Just take what's on the periodic table. So we keep going. 1 calcium. Remember, this one would have 2 nitrogen and 6 oxygens. You'd have to find out, 6 times 16, 2 times 14, and then calcium's 23. You'd have to add all that together. But that's a formula mass. Why? Because it's a formula unit. It's a metal bonded with a non-metal grouping. This one would be a molecular mass when we add it all up after you multiply 6 carbons, 12 hydrogens, and 6 oxygen, because that's all nonmetals. So it's a molecular mass. Now, this last one's going to be a formula mass. I know that doesn't start with, it's the one example of a polyatomic ion that is a cation. That's a positive one. Kind of just threw an extra one in there. So what do you got to do here? 5.69 grams. If I want to change it to moles, start with what's given in the problem, 5.69 grams. I'm going to put the number of grams on the bottom and 1 mole on top, which means it's going to be a division problem, but I have to add up 1 sodium, 1 oxygen, and 1 hydrogen first. That's what I divide. I get the 5.69 divided by that number. So I kind of show you here. Again, putting in the parentheses, you get to see example here. 5.69 grams is what I start with. 40 grams per mole, that's when I add all of that together. And then the grams cancel. I'm left with moles. You divide because the number's on the bottom. Now, that told us how to do mass, told us how to do representative particles. We still got to do volume. Volume's the easy.